Hello everyone, I'm Amit, and in this particular session we are going to learn about software concepts, and specifically we'll be talking about system software, right? So let's begin with the software concept. So software, as per definition, is a set of programs that governs the operations of a computer system and make the hardware run. First of all, we should understand what is a program. A program is a sequence of instructions which is given by us to the computer. Obviously, they are written in a language which can be understood by the computer, that we know computer understand only the binary language, machine level language, to solve a particular problem. So, or to make the hardware run. So, basically, set of instructions to solve a problem is called a program, and set of such many programs which can help us to govern the operations of computer system as well as to make the hardware functional is called software, right? So software is basically a collection of programs. So if we classify software can be classified into system software, utility software, application software, as well as libraries. And we will be talking about only system software in this particular session, that is operating system and language translator. And in language translator, we will be understanding about compiler, interpreter, as well as assembler, right? So first of all, we start up with the system software. A system software is a software that controls the internal operations of the computer system. As we have already discussed, it actually provides an environment for running the application software programs on it. It has various functions like reading the data, receiving the information, translating the data and instruction from high level language to machine level language, as we provide the input in high level language, but the computer understand it in the machine level language. Higher level language can be English, which is printed on our keyboard, but machine level language is the language of zeros and ones. It's a binary language. It's a language of electrical signal which computer understands. It controls all the peripheral devices. What are peripheral devices actually? Peripheral devices are like printer, scanner, camera, etc. Those are enhancing the efficiency of the computer system to make it a multifunctional device. So after that, it helps in processing and generating the output, obviously in back to the high level language, because we feed everything, we input everything in the high level language, but computer understand it in machine level language and process it and generates the output back in that particular language which we understand. These are the functions of system software. So if we categorize the system software, it can be categorized in two ways. First is like operating system, second is language processor. And operating system is an interface between the user, means the we, and the hardware, whereas the language processor basically translate a high level language or assembly level language into machine level language. Now high level language is called source code, whereas machine level language is sometimes called object code or machine code, right? As I have already told you that high level language is the language which we understand, like English, and machine level language is the language which computer understand, that's the binary language, right? So we start with the operating system. So if we talk about operating system, it helps in managing the resources of computer. Resources can be hardware as well as software. Basically, we focus on the hardware part, right, and optimize its performance, right? So operating system is the first program executed on a computer after the BIOS. What is BIOS? Basic input output system. When we start our computer, a power on self test is conducted in which computer system checks that whether all the peripheral devices are functioning properly. After that, it starts the bootstrap procedure, and booting of the computer starts. When the booting is done, at the time the operating system is actually loaded from the first boot sector of the computer, the hard disk in fact, to the RAM. So basically operating system is the first program executed on the computer system after the BIOS. So operating system identifies input-output devices and also accepts input from input devices, sends the output to the output devices. Operating system keeps track of files and directories. As you can see that when we open an operating system, say window. So when we open window, everything is organized in the form of disk partition, C drive, D drive, E drive, and after that there are some folders and which are also called as directories, and in folders there are files. So this is organized like an office. So this thing is being provided by the operating system and done by the operating system, in fact. So operating system also control the peripheral devices. Peripheral devices I already told you, like printer, camera, scanner, etc. Now, if we talk about some example of operating system, this is Microsoft's Windows, Apple's Mac OS, and for mobile, which is more or less a computer nowadays, Android is there, and another open source software operating system is there, which is called Linux, right? So now, what is the need of operating system? Now, for user interface, as I already told you that operating system provides an interface between the user and the hardware. Now, there are two types of interface. One is black and white screen. You type the command, you give the instruction, and it performs the particular task. This is more or less was done in Unix, Linux, etc. But nowadays everything is in GUI, graphical user interface, where we see colorful screens, icons, the figures or icons represents certain things. For example, if we talk about a trash or a recycle bin, it has a bin made there. So obviously by seeing that graphic, we understand what is the purpose of this particular application. So this kind of interface is provided by the operating system only. Now, program execution, loading the programs into computer memory. Like if we double click on any application, it starts. How it starts? It is somewhere stored in the hard disk, but from the hard disk it get loaded into the RAM and it get executed. Now, this is also done by operating system. Resource allocation, CPU time and the memory are the two important resources of computer, and at which time and to which device they are to be allocated, this is also decided by operating system. Now, manipulation of file system, as I already told you, like storage and retrieval of information from the hard disk, from the folder, from the files. This is also managed by operating system, and handling all the input-output operation. Obviously, if any input-output device is functioning properly or not functioning properly, it is being conveyed by the operating system to the user that some cord is not connected or some input-out signal issue is there. The dialog box, actually it communicates with the user that what is happening with the hardware, right? So error, the next point is linked to this, error detection and handling. It sees that what kind of error has occurred, it conveys to the user, and also suggests him that this thing is maybe the reason for this particular problem, so you can resolve them by following the procedure. So it also controls various hardware and software, as I already told you, application software as well as peripheral devices. Now we talk about the language translators. Language translators are basically assembler, compiler, and interpreter. Three kinds of language translators are there. When we will talking about assemblers, we'll talking about mnemonic codes, and compiler, you remember this line, whole program at a time, and interpreter is line by line. They are the hints to remember the functions. So first of all, assembler. Assembler is a language processor which is used to translate the program from assembly level language to machine level language. Now, first of all, we should understand what is assembly level language. Now, assembly level language is a language of mnemonic codes. What is that? Now, actually, when this programming thing started, at the time everything, every computing was done in the binary codes. So the programmer or the operator who operates the computer, he was the person who was having all the knowledge about the binary codes for all the operations, as well as all the means numbers and alphabets. So he must be knowing everything. Means if you want to do 6 plus 6, so you should know the binary code of 6 as well as plus. So in this way, but when the mnemonic codes came, they made the task a little bit easy. They are actually operational codes. Like for addition, you don't have to remember the binary code, but you can press the add button. For multiplication, you can go for MUL. For subtraction, you can go for SUB. So these are the few things which were provided in the assembly level language. These codes are called mnemonic codes, and the purpose of assembler is to convert the source code, which is high assembly level language, into the object code. Object code is basically binary language. Right. Now we talk about compiler. Compiler is a language processor that translates the complete source program written in high level language, that is English of course, as a whole in one go. Means it reads the program like the source code, compiles it. Compiles means it converts it whole program at a time into the machine code, that is binary language, and if there are errors, it reports them, and after we remove the errors, it gets executed. So it is the following task. But the compilation actually, the compiler actually tells the line numbers of the program at which there are errors. Right. Interpreter is a language processor that translates single statement of the source program at a time. It also converts high level language into low level language. Same thing, but line by line. What happens actually? It reads a line, converts it into machine level language. If there is error, it reports the error. Until you resolve the error, it won't move to the next line. This is the only difference. So if we differentiate between these two things, compiler and interpreter, compiler actually debugs the whole program in one go, whereas the interpreter debugs the program in line by line, or translates it. Now, errors traced are displayed at the end of the program along with the numbers in case of compiler, right? But in case of the interpreter, as we know, it first when it converts one line, it sees if there is an error. It won't move to the next line until you remove that error. And in case of compiler, less memory is consumed when it runs, whereas in case of interpreter, it is comparatively more. And the execution time for compilation is less in comparison to the interpreting time. So obviously the interpreter are more accurate kind of thing, and the compiler are less accurate, but in case of speed, they are more fast as comparison to interpreter. This is all about the topic. You can refer these two books for quality resources, and thanks. Feel free to ask any question on this. Thank you.